Welcome. Today we'll find the derivative of y equals secant of tangent of x. This is a composite function that will require the chain rule multiple times. Let's break this down step by step using the chain rule. Remember, the chain rule states that if y equals f of g of x, then the derivative dy dx equals f prime of g of x times g prime of x. In our case, we have a composition of two functions. The outer function is secant, and the inner function is tangent of x. First, let's recall the derivative of secant. The derivative of secant x is secant x times tangent x. And we also need to know the derivative of tangent x, which is secant squared x. Now, let's apply the chain rule. The derivative will be secant of tangent x times tangent of tangent x. That's from the derivative of the outer function times the derivative of the inner function, which is secant squared x. Let's organize this visually to see how we got here. Let's highlight the key parts of our solution. This first part comes from the derivative of secant, evaluated at tangent of x. And this last part is the derivative of tangent x. And that's our final answer. The derivative of secant of tangent x is secant of tangent x times tangent of tangent x times secant squared x. This problem demonstrated the power of the chain rule in finding derivatives of composite functions. Remember to identify your outer and inner functions, know their derivatives, and apply the chain rule carefully.